So before we begin, make sure you have all of these files. You'll need all of the MATLAB files as well as the Parasolid listed on the website. First thing we're going to do, once we've opened NX, is open a new model, and I'm going to name my model 6.9.3, and you'll change that depending on whatever the wheel is that you're using, and then you'll change the place where you're going to put them, the folder where you're going to put all these files, to whatever folder you desire. Now that we've opened up our new model, I'm going to start by importing a Parasolid, and that Parasolid is going to be the wheel file that I have. And I'm going to hit start. I'm going to start an advanced simulation. And in this advanced simulation that I've begun, I'm going to begin a new FEM and simulation. Before I move on, I'm going to hit geometry options and make sure all of them are included, and then I'm going to hit OK. As it creates a new FEM and simulation for me, I'm going to name my simulation whatever type of load that I'm going to be working on. So the type of load I'm going to be working on is the static load. And hit OK. One change you're going to notice is with the new update, you no longer have to partition the wheel, so we're going to begin in the FEM. I do assign a material to my model. Go ahead and click on the wheel, and that selects it as the part that I'm going to be assigning the material to. And I'll scroll down to the material that I want to use, which in this case is the magnesium. So hit magnesium, hit OK. And then I'm going to create a 3D mesh. Go ahead and select the part again. And note that I'm going to keep it in C tetra 4 for the time being, and I'll go ahead and keep a rather large element size of 10 millimeters. Scroll down, and remember I have to create that new mesh collector. Hit New Physical, and make sure it's the magnesium cast material. I'll go ahead and name it magnesium to keep everything together, and hit OK. And now I'll rename the mesh collector magnesium as well. I'll spell it correctly. And I'm ready to go. Hit OK. Now while it's creating the mesh, I'll go ahead and fast forward this, but it'll take a little bit longer for you guys. This is about sped up 16 times. Yay, VLab. All right. Now we're done with the FEM, so we'll move up to the sim. The first thing I'm going to do is go ahead and constrain the 4 bolt holes around the center of the wheel with a fixed constraint. Make sure I'm using the polygon face. That's what I want to select to fix, nothing else. And I'll go ahead and select the faces inside of those 4 holes, or those 6 holes rather. Make sure I got the right one there. Nope, that one. There you go. Okay, and now those will have a little blue circle around them. And now I'm going to head over and I'm going to apply a pressure load onto the outside of the wheel, and that's going to be symbolized as the tire pressure. Tire pressure is going to hit equally on all surfaces of the wheel. It'll be normal to the wheel surface, and that's kind of intuitive. We kind of understand why that is, because the air from the inside of the tire is going to be pushing equally on the tire around the entire thing. Entire. Go ahead and rotate this so I can see the whole thing. Make sure you hit all of the faces in the middle. You have to do one at a time to make sure you get it all right. There you go. Now that I've selected all of the faces, I'm going to hit OK. Oh, but first, I have to know the magnitude of the pressure that I'm applying. So I'm going to go look that up. Under mechanical team, the wheel FEA, it says right at the top there that I want a 500 kilopascal load. I'll go ahead and input that right now. Select kilopascals and type in 500. OK. All right, now, the next thing is the type of load, the special type of load that I've assigned to you guys. I'm doing the static load as just an example. And just so I can keep everything nice and clear, I'm going to hide that for the time being, hide the pressure load that I just created, and zoom out so we can see everything. Now, before I do go ahead and apply and run the MATLAB code, I need to get all of the information about the nodes and the elements that of the bead seats on which I'm going to be applying this load. Go ahead and zoom in and hit both of the bead seats. There's one of the bead seats. Remember, guys, the bead seats is the part of the wheel's rim that the tire is resting against. Let's see exactly which of those faces is the bead seat. Again, keep in mind it's the polygon face and you're hitting all related nodes. I've selected both the bead seats. I'm going to hit OK, and that'll generate a file full of all information regarding all of the nodes that we've just selected. That's going to take a little while to generate all of this. But this is how it should look. Hit Save As. And this is very important. I have to save it in the same directory as the MATLAB files. I'm going to call this nodes.txt. The same thing for the elements now. The exact same thing. Again, make sure related elements and polygon face. Now I have to click both bead seats again. So again, I'm going to save as elements.txt, this file that it's created, with all the information about all of the elements. And these two files that you've just created are going to be read by the MATLAB code that you've been given. And we're going to generate the forces that need to go on those elements. So I'm going to go ahead and open up MATLAB, just making sure that I have it right here in the Start menu. But I'll go ahead and open up the code directly. You'll click on whatever code you've been assigned. So maybe it's the bump load or the brake load, one of the two cornering loads. The 3 simulations we have to run, or the 4 simulations rather we have to run. Here's MATLAB. That's going to take a little bit of time. There we go. There's my program. See, it's not like super complex, but oh well. Go ahead and run it. Over in the command window, you're going to see that it ran, and it has a little done thing that pops up when it's all ready for you. And that's just generated a nice file called loads.bdf. I'm going to go back into here, and underneath solution, I'm going to right-click on solution. I'm going to hit edit. And underneath bulk data, under user-defined text, I'm going to insert some new user-defined text. I'm going to call it the static load. And then in the key in text, I'm going to hit that little box right there to key it in. And now it gives you this little pop-up window. You should see like a little white square where I can input text, but instead I'll just open it up. I can open up a PDF file called loads.bdf. It's in the same directory as the MATLAB code. In a Word document, make sure it's in Word, or Notepad++ should work too. But anyway, copy everything and hit paste. Make sure you hit paste right there, and don't hit Control-V, don't hit right-click paste. Make sure you hit paste within that window. And then you can kind of see it's written right there. It's a big file, a lot of forces. Hit OK. One more thing we have to do is tell it where that is, the label that it has. So go to Case Control, and same thing. Scroll all the way down to user-defined text. And in that key in text, down at the bottom, I'm going to hit load equals 3. No spaces, just load equals 3, all caps. Now I've typed that in, and I'm going to hit OK. Hit OK again. And you can't see it, but it's there. So now I'm going to hit check right next to that static load. Hit solve. And hit OK. And this is the part where you type really fast to impress everyone around you, because it looks like you're typing a bunch of really impressive code in, when in reality it's doing this all for you. And then now at the bottom, eventually you should say job finished. You can close everything, all these random pop-up windows that have popped up. And scroll down to the very bottom and hit results. And you can click the elemental stress, and you can see the stress distribution across the wheel, how it's deformed. The thing we're paying attention to again is the redder colored areas, the warmer colored areas, how that stress dissipates. But the main thing we're worried about is that maximum stress experienced right there. But for the time being, just save this and you're done.